Algebra kids. We are going to go back to chapter 4 and start with chapter 4 now, which is operations with polynomials. You guys should have this note sheet already, but I'm going to go ahead and give you a new one because I know some of you have lost it already. And then I'll go through all of this again, just because it's very, very important. I know that we've gone through this already once, but it's very, very, very important that you understand how to do section 4.1 at least. So we're going to start from scratch. Grab your note sheets, fill in exactly as I fill it in, and we'll try to go through this pretty quickly. So I'm going to go through this box again like I did before, and I'm going to give you better examples because I don't like their examples all the time. So product of powers, what this means is if I have, like, let's say x squared times x cubed, when you're multiplying x's together, what you're going to do is you're going to add the exponent. So that actually becomes x to the 5th power. Okay. I'm going to bump down to power of a power property. I remember talking to you guys about this before. People get these two switched around all the time because they look at x squared cubed and they look at x squared times x cubed and they're like, oh crap, which one is which? This one is x to the 6th power. If you have two numbers that are right together like that, you are going to multiply those numbers. When there's an x in between them and you're multiplying the x's, then you're going to add the powers. So this is an example of power of a power. This is product of a power. So you're multiplying the x's. This, you have two powers going on right together, and you're going to multiply those. Okay. Quotient property would be like if I have x cubed over x squared. What you're going to do is you're going to subtract. Here, when you're doing product, you're adding the exponents. Here, you're going to subtract the exponents. So that would be like 3 minus 2. So that's just going to be x to the 1st power. Okay, you're going to subtract those exponents. Right? We'll do some examples over here in just a second. Negative exponents. Whenever you have a negative exponent, I'll do two examples here. Let's say I have x to the negative 3rd power. Okay, that's going to be 1 over x to the positive 3rd power. You kind of like move him down to the denominator. Okay, and then I'm going to do another little short example. Let's say I have 1 over x to the negative 4th power. Okay. Him, I'm going to move to the top. So that's going to become x to the positive 4th power over 1, or just x to the positive 4th power. So you guys, probably some of you remember these rules, but this is just reinforcing that you really, really, really need to know how to do these. Okay. After power of a power, there's power of a product. So what this one is kind of saying is that, like, let's say I have x squared, y cubed, and then I have to the 4th power. Okay. This 4th power, if I have two pieces in here, that 4th power needs to be distributed for both of those. Okay. Now here's the question again. Do I add those or do I multiply them? The two numbers are right together, so you're going to multiply. X squared to the 4th power is x to the 8th power. Y cubed to the 4th power is y to the 12th power. So there's power of a power. You're distributing that exponent through there. Okay. Power of a quotient, the same thing works. Like, let's say I had x squared over y cubed, and that was to the 4th power. Okay, same thing works. Even though it's not a product, it's a quotient, it's still going to end up x to the 8th power over y to the 12th power. That 4 gets distributed for both of those pieces. Okay, and then the last one is the 0 power. Anything to the 0 power is always 1. Circle that really big on your note sheet so you can get that. Okay, x to the 0 power is 1. Y to the 0 power is 1. 2 to the 0 power is 1. 121 to the 0 power is 1. Okay, anything, variable, number, anything to the 0 power is always 1. Okay, always remember that. All right. Let's go up to some of these examples up here. Simplify the expression. When you have parentheses like this, there's 3 sets of parentheses. That means I'm multiplying all 3 of those pieces together. Okay, so I want to put the like stuff together. I'm going to multiply the like stuff together. So I start with the numbers 2, 3, and then there's no number over here, which means there's like a number 1, an imaginary number 1. Okay, let's deal with those first. 2 times 3 times 1 is 6. Okay, so that gets rid of the numbers. Okay, now a to the negative 2nd power a to the third power, and then there's no a over here, okay? When they're next to each other like this, they're in the form of the x squared times x cubed. I'm going to add those exponents. So a to the negative 2 and a to the third, I add those, and negative 2 plus 3 is a to the first power, or just a. If you don't like to write the 1 up there, you don't have to. So that gets rid of my a's. Cross things off. B to the second power has nothing to go with, so we're just going to write b squared. And then c to the negative second power doesn't have anything to go with either. Okay. Now, if you leave your answer like this, I will be grumpy because c to the negative second power, I don't like negatives in my exponents. Okay. How do we get him to be positive? We move him to the denominator. We move him down below here. So he's going to become c squared, and he goes away. All right, let me rewrite that so it's better. 6ab squared over c squared. That's what he will look like. Okay. All right, part B. What you want to do here is combine the like things, so the q's will go together and the r's will go together, okay? Q squared and q to the 7th power. I want to put the 2 and the 7 together, and I'm going to subtract them. So what I'm going to do is I always take the higher power minus the lower power. So 7 minus 2. 7 is the bigger number. 7 minus 2 is 5. Now, does q to the 5th power go on the top? Or does q to the 5th power go on the bottom? It goes on the bottom because q to the 7th power is the bigger one, and he is on the bottom. So q to the 5th will go on the bottom because the 7 was larger. Okay. R to the 4th power and r to the 3rd power. 4 minus 3 is 1, and he's going to go on the top because 4 is bigger than 3. So r to the 1st power is going to go on the top, just like that, and there's nothing else I can do. So there we go. All right. Part C. This cube is on the outside of all of this junk here, and I have to distribute him through. The biggest mistake I see people make, though, is they don't distribute it through to the negative 2. So we've got to take negative 2 to the 3rd power. Negative 2 times negative 2 times negative 2 3 times is negative 8. Okay. A to the 4th power and then to the 3rd power, I multiply those, so 12. And then b squared to the 3rd power, multiply again, is b to the 6th power. Okay. Now, people look at this and say, wait, we're not done yet because there's a negative. Well, the negative's in front of the number. It's not in an exponent, so we are actually done. We don't have to go any further. The negative is in front of the number. It's not an exponent. So our exponents are positive and we're done. Make sure you do the 3 to all 3 pieces, though, not just the a and the b. Negative 2 has to be multiplied by the, or done cubed by the 3. Okay? All right. Now they're going to talk about polynomials down here. The degree of a polynomial is the degree of the monomial with the greatest degree. I remember reading that before and thinking, what in the heck does that mean? Okay? So we're going to look down here at some examples. Part A, I have 2 pieces. This piece right here and this piece right here, and they are separated by a minus sign. Okay? Now what I'm going to do is individually, looking at each one of those pieces, I'm going to look at the degree. So this x to the 5th power, he is a 5th degree. There's no other choice. He's by himself. He's a 5th degree. But this one right here has an x and a y. So is his degree 4 or is his degree 3? His degree is actually 7. You add those 2 together and this is a 7th degree. Okay, now if I'm looking at this entire thing and wanting to know the degree of that polynomial, I look at the higher one. I don't add them together now. I add them together individually, but I don't add them together now. 7 is the bigger number, so this is 7th degree. Okay? All right. Part B. There's a problem with this. In the instructions, determine whether each expression is a polynomial. This one is not a polynomial. Polynomials are only things that have positive numbers. So here are things that are polynomials. Yeses are x squareds, xy cubed z to the 5th power, y x z w r. Those are polynomials, okay? Anything that has positive exponents, things that are not polynomials, are square roots. X to the negative third power, no negatives. 1 over x is not a polynomial. None of those are polynomials, so those will not work, okay? So B, this is not a polynomial, and I circled the bad part, okay? C, is he a polynomial? No. -3 and -2, those exponents will not work, so no, not a polynomial, all right? Okay? Example 3, simplify each polynomial expression. First, we got to decide what they're even asking us to do. I see a parentheses here and a parentheses here, and they are separated by a minus sign, which means subtract. So what I'm going to do is I'm going to take this guy and I'm going to subtract this guy. All right? I'm just going to rewrite what this first piece looks like. 4x squared minus 5x plus 6. I'm subtracting this piece right here, but there's 3 little guys inside of here. So what I need to make sure and do is I need to change all of them to be negative. So this 2x squared becomes negative 2x squared. This positive 3x becomes negative 3x. And this negative 1 becomes positive 1, because negative 1 becomes plus 1. So whenever there's a minus sign, you need to make sure you distribute it through all pieces. All right? Now I'm going to combine like terms. 4x squared and negative 2x is 2x squared. Cross those off. All right? Negative 5x and negative 3x is negative 8x. And 6 and 1 is 7. And there we go. That's all the further we need to do. All right? This one is plus. So I'm taking these 2 pieces and I'm adding in between them. All right? If I distribute a positive times negative 4x, this becomes negative 4x. That's square root. Positive and positive 9 becomes positive 9x. Positive and negative 5x. So really, the positive doesn't change this guy at all. He just becomes what he was before. We're just adding them together. 6x squared minus 7x plus 8. He doesn't change. There's no symbol in front of him to change him. So now that we have that going on, we're just going to combine like terms. 6x squared and negative 4x squared. 6 minus 4 is 2. Cross them off. The negative 7x will go with the 9x. That's positive 2x. And the 8 and the negative 5 will become 3. And there we go. If that was too fast, if any of that was too fast, feel free to pause this video and rewind it, or you can watch it as many times as you want to. I know that's going to happen to a lot of you. That's a lie, but if you want to rewind, you sure can. Okay? All right, example 4. I'm going to skip example 5, by the way. I don't want to do story problems right now. Example 4, though, they want us to use the distributive property. Distribute means you're going to multiply through for all of pieces. Okay, this guy right here has 1, 2, 3 pieces. So I'm going to multiply him through by all 3 of those pieces. 3x times 2x squared is what I'm going to do first. 3 times 2 is 6. And x times x squared becomes x cubed. I add those exponents. This is x to the first power. Right? 3x times negative 4x. 3 times negative 4 is negative 12. And x make x squared. Okay? 3x and 6. I just multiply those numbers. Makes 18. And I drag the x along. That's all I can do. That's it. Pretty easy. Okay? All right. And then multiplying polynomials. So this one's kind of like the distributive property. Kind of like the FOIL method a little bit, but the FOIL method only works if you have this guy times another binomial. Okay, this is 3 pieces times 2 pieces. Okay, so what will happen here is we're going to start with this first piece. So maybe circle that first piece, n squared. Okay, and what I want to do is he's in that first set of parentheses. I want to multiply him by the stuff that's in the second set of parentheses. And there's 2 pieces over here. So I have to multiply him first by the first piece, and then multiply him next by the second piece. Okay, so n squared times n will be n to the third power. N squared times 2 is 2n squared. Okay, and don't forget that plus sign in between them because it's a positive 2n squared. Okay, now this n squared is done. We've multiplied him by both of those pieces there. All right, then I'm going to worry about the 4n. 4n is next. All right. 4n is going to be multiplied by both of the pieces over here. Right? 4n times n will give me 4n squared. 4n times 2 is 8n. And now the 4n is done. Okay. The last one is negative 6. I'm going to take negative 6 times n and negative 6 times 2. Negative 6 times n is negative 6n. And negative 6 times 2 is negative 12. Okay? If you look at your final answer before we simplify, because we're not quite done yet, I have 1, 2, 3, 4, 5, 6 pieces. Okay? Now, I have 6 pieces because I took something that was 3 pieces times something that was 2 pieces. And 3 times 2 gives me 6 pieces. Okay? So that's kind of a way of checking yourself to make sure you've hit all the pieces. Each piece of this guy should multiply by each piece of this guy. Now let's put stuff together. N cubed. Will he go with anything else? Any other n cubes? Nope, just n cubed. All right. N squared. There's another n squared right here. And positive 2 and positive 4 make positive 6. That's n squared. Okay. 8n and negative 6n. That's positive 8 and negative 6 makes positive 2n. And negative 12 goes by himself, and that's it. Okay? All right, I'm going to do one more example real fast. Let's say I have 2x plus y, and I want to do, oh my goodness, I'm going to do something really crazy. We're going to take him to the 4th power. Taking him to the 4th power, oh my goodness. Well, what that means is I'm taking 2x plus y times 2x plus y times 2x plus y times 2x plus y 4 times. Okay? Now, what people will sometimes do, and plug your ears if you get confused easily, because this is something that I do not want you to do. Some people will look at this and say 2x plus y. Well, that just means 2x to the 4th power plus y to the 4th power. I wish it was that easy. It's not. It's this times this times this times this 4 times, okay? Do not do this, okay? So what we're going to do is we're going to FOIL this, but we're going to only do a couple pieces at once. Let's just do those 2 pieces. Let's just multiply those 2 pieces together. So 2x times 2x. We're going to start with this guy and multiply him by both of those pieces. So 2x times 2x is 4x squared. 2x times y is just 2xy. Okay? Then he's done, and now I'm going to go with the y. Y times 2x is another 2xy. And then y times y is y squared. Okay? I just did the FOIL method. First, outside, inside, last is what I just did. All right? Now, this guy right here can be simplified a little bit. So 4x squared, 2xy and 2xy will become 4xy. And then I have y squared. So I just combined these middle 2 pieces to become that guy. Okay? So this is what I have here for these 2 multiplied together. All right, now I'm going to make your life really, really easy because we still have to worry about these 2. But since all 4 pieces are the same thing, these 2 multiplied together will be just the same as what we have here. 4x squared plus 4xy plus y squared. That's what we will have. And now I only have to worry about multiplying this guy and this guy together. Okay? All right, now, this guy has 3 pieces. 1, 2, 3. And this guy has 3 pieces. 1, 2, 3. We have something that's 3 pieces times 3 pieces equals 9 pieces. Oh my goodness, this is going to be crazy. So here's my first piece, 4x squared. I'm going to take him times this guy, and times this guy. All right, 4x squared times 4x squared is 16x to the 4th power. 4x squared times 4xy. 4 times 4 is 16. X squared times x is x to the 3rd power, and then I just have a y hanging off. Okay? 4x squared times y squared is 4x squared y squared. And now he is done. I have multiplied him by all 3 of these pieces. Okay? Now we're going to do the 4xy, and we're going to multiply him by all 3 of the pieces. All right? 4xy times 4x squared. 4 times 4 is 16. X times x squared is x cubed. And y times nothing over here is just y. All right? 4xy times 4xy is 16. X and x make x squared. Y and y make y squared. If I'm going through this too fast, pause. All right, last one is 4xy times y squared is 4xy to the third power. 4x, and then there's 3 y's. Okay, middle piece is done, and I'm running out of space over here. Y squared times 4x squared gives me 4x squared y. So we're just combining all 3 of those pieces together. Then I take y squared times 4xy is 4xy to the third power. And y squared times y squared is y to the fourth power. Now notice that I'm separating each one of these pieces by a plus sign so they don't all run together. That's how I know I have individual pieces. We were supposed to end up with 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, but we still have to combine things if we can. So let's look at 16x to the fourth power. And the other x to the fourth power. There's a y to the fourth, but those can't go together. So I just have 16x to the fourth. All right? Now, we have an x cubed and a y. X cubed y. Any other x cubed y? That's an xy cubed, but that's not the same. So we're going to combine these two. 16x cubed y and 16x cubed y. Adding those two together will give me 32x to the third power y. And we cross them off. X squared, y squared. There's an x squared, y squared. Another x squared, y squared. No. So 4 and 16 will give me 20. X squared, y squared. And we cross those off. Okay. Couple more. 4xy cubed and 4xy cubed will give me 8xy cubed. 4x squared y. You can't go with anybody. And then y to the fourth power. So still really ugly, but it was kind of a shortcut here because we had 4 of them, so we kind of skipped a step. So that's something that you will run across here, I know for sure on one of your homework assignments. So keep that in mind. There you go.